Hey, it's Mr. N here, and we are going to do the Chapter 11 review. This is the in-class one, and here's the video for it. So let's start with the first problem. The first problem says, find the volume of each. So suppose we had a cylinder with a height of 4 and a radius of 3. So in this case, we've got our right circular cylinder, and that should be indicated in the problem that it's a right circular cylinder. The height is 4, and the radius right there is 3. So the volume of a cylinder is pi r squared h. So the radius in this case is 3, and the height is 4. So pi times 3 squared times 4. And that would be our volume. Our volume is going to be 9 times 4, which is 36 pi. Now you can leave it, and this is cubic centimeters. On the test, I didn't say whether to leave it in pi or decimal, so I'll take either answer, whether you want to leave it in pi form or multiply it out and give me a decimal. All right, for problem number 2, we have a triangular prism with a height of 9 and sides 6, 7, and 10. We're going to change this problem a little bit. We're going to make these 6, 10, and 10. It'll just be a little bit easier for now for our application. So let's take a look at this. And we've got this triangular based prism. And these are 10, 10, and 6, and this height is 9. So the volume is the area of the base times the height for a prism, which means I need the area of this base. And the area is this triangle that's 10, 10, and 6. So what I can do is I could drop this altitude down, and this becomes 3. So now I can solve for the height by using the Pythagorean theorem. So if I say 3 squared plus h squared equals 10 squared, I can go through and solve for the height. So I'll get h squared is going to be 100 minus 9. So h is going to be the square root of 91. And let's get that as a decimal. We'll work with that as a decimal now. And that comes out to be 9.54. So the height is 9.54. So over here I end up with the volume being 9.54. That's the area of the base. Sorry, I need to multiply the whole base. The base is going to be 1/2 times 9.54 times 6. So this is the area of the base, the area of this triangle. 1/2 times this whole base times that whole height. So 1/2 times 9.54 times 6. So that's what I'm going to put in here. 1/2 times 9.54 times 6. That is the value of that base area. And then the height of the whole prism right here is 9. So times 9. So let's multiply all that out. 9.54 times 1/2 times the 6 times the 9 gives us 257.56. So the volume is 257.56 cubic inches. All right, moving on to the next question. We have a square-based pyramid, and on our square-based pyramid, we have a height of 4 and sides that are 3. So we end up with this kind of square-shaped based pyramid like that. And on this, the sides are all 3, and the height of the pyramid itself, the height inside, is 4. So we know the volume of a pyramid is 1/3 the area of the base times the height. It's very similar to a prism, but 1/3, and we talked about why it's 1/3. So 1/3. Now the area of a base is the square, which is 3 by 3. So B is 3 times 3. So 3 times 3. And then the height of this pyramid is 4. So multiplying all this out, we get 12 cubic centimeters. So again, you have your formulas. You need to memorize your formulas. I gave you a formula sheet on the website that you can download, and it's all in one page, so it'll be handy for you there. All right, number 4 says a regular hexagonal prism with a height of 10 and base edges 4. So this time we've got this hexagonal prism. Tough to draw. And these should be dotted in the back. So anyway, I'm going to put it right here so you can see that this is the hexagon I'm dealing with. And the base edges are 4, so that's 4 like this. So this is this hexagon. And the height of this thing is 10. So we know the volume is going to be the area of the base times the height. So now we have to find the area of this hexagonal face. Well, to do this, we've got a hexagon, and we talked about something special that happens with hexagons. And what happens is, since this is a regular hexagon, even though I didn't draw it so well, if this piece is 4, then this radius ends up being 4 as well. This ends up being 4. And we said that because we can fit 6 equilateral triangles in a regular hexagon. So that's how we know that. So in this case, since we need to find the volume, I need to find the area of this base. Well, the area of this base is a polygon, and the area is 1/2 the perimeter times the apothem. So that means I need to solve for that. That's my apothem. So the perimeter is 4 times 6. There's 6 sides. So the area will be 1/2 times the 4 times the 6. Now, again, this area is this base area. Times, so we have 1/2 times the perimeter. And now I got to multiply this by the apothem. Well, I got to solve for this apothem. Again, we broke this triangle apart. This was 4, this is 2, because it was 4 all the way across. When I drop this down, it cuts it in half because it's equilateral. So this is my apothem. A squared plus 2 squared is 4 squared. So a squared will be 16 minus 4. So a squared will be 12. So a is the square root of 12. And again, let's just work with that as a decimal right now. So the square root of 12, because you could simplify this, but we're going to go ahead and work with it as a decimal. And that's 3.46. So a is 3.46. Let's go ahead and get this whole answer right here. So 1/2 times this 3.46 value times the 4 times the 6. Multiply all that out, you get 41.52. So the volume is 41.52 times the height that I have, which is 10. So that's going to give me 415.2 as my answer, and that's cubic meters. Okay, number 5. Moving right along here. On number 5, we are asked to find the volume of a sphere, and I also ask for you to find the surface area of the sphere. So the volume, I've got a sphere here, and this radius is 3. So the volume is 4/3 pi r cubed. Well, that's going to be 4/3 times pi times the radius, which in this case was 3 cubed. So the volume will be equal to 3 cubed is 27, divide that by 3 is 9, times 4 is 36 pi. And that's cubic inches. So the volume is 36 pi cubic inches. The total area, which is the surface area, is 4 pi r squared. That's 4 pi times 3 squared. That's also going to end up being 36 pi square inches. So that one ends up being 36 pi square inches. The volume ends up being 36 pi cubic inches. For number 6, we have a cone with a height of 10 and a radius of 2. And we also want to find the surface area of this cone. So we've got this cone, and the height is 10, so h is 10, and the radius right in here is 2. The volume of a cone is 1/3 the area of the base times the height, 1/3 pi r squared h. It's pi r squared because it's a circular base. So the volume ends up being 1/3 times pi times the radius, which is 2, squared, times the height, which is 10. So working all this out, you would get 2 squared is 4 times 10 is 40. Divide that by 3, and you end up with 13.33 pi. Or you could have said 40 over 3. And this is, I didn't indicate units, so we're going to say units cubed. Okay, so now for the surface area, we've got the total area, and that's going to be the total surface area, and that's pi RL for a cone. So for a cone, we've got the pi, we've got the radius, which is 2. Now we need the slant height. And the way to get that slant height, this is the L right here. We know this height is 10, we know that's 2, so we have this triangle inside. We cut that triangle out, and we end up with 2 here, 10 there, and L as my slant height. So 10 squared plus 2 squared is going to be L squared. So 104, the square root of that is what L is going to be, and we can put that in there. So this becomes pi times 2 times the square root of 104. And we will do this as a decimal, so the square root of 104 divided, or times 2 gives us 20.4 pi, and that's square units. If you multiply it all out with the pi, you will end up with 64.04. So either way, I'll take the answer. Okay, for the next problem, we have a sphere with a volume of 200 pi. What is the radius? What is the surface area? All right, let's see. So on my sphere, there's my radius, and I've got a volume of 200 pi cubic centimeters. And the volume is equal to 4/3 pi r cubed. So I can go through and solve for that radius. So the pi's will reduce out, and you'll end up with, multiply each side by 4/3, or 3/4, sorry. So 200 times the 3, and divide that by 4, you will end up with 150 equals r cubed. That means r is going to be the cube root of that, which ends up being 5.31. So r is approximately 5.31, and that would be centimeters. We answered the first part. What is the surface area? Well, the surface area is going to be 4 pi times this radius, 5.31, squared. So square that radius times 4, and you get 112.92 pi, and if you multiply this all out, it'll be 354.4 7.58 square centimeters. And either answer is fine. All right, for number 8, a cone has a height of 10 and a volume of 200 pi. Find the slant height. So again, we've got a cone, and the height of this is 10, and the volume is 200 pi. So the volume is 200 pi. And the volume of a cone, and we did this in the previous problem, is 1/3 pi r squared h. So 200 pi equals 1/3 pi. We don't know the radius, but we do know the height, so I can go through and solve for that radius. So the pi's will reduce, and we end up with 200 times 3, so we can get rid of the fraction. That's 600. Then divide that by 10. That's 60 equals the r squared. So take the square root of 60. R is going to be 7.75. So it's approximately 7.75. Now, we needed that because we had to get this slant height L. So, we've got this as being 7.75, the height as being 10, and we can use this right triangle that we have to find the slant height. So L squared equals 10 squared plus 7.75 squared. So square our 7.75 plus 100. So this 7.75 squared should end up being 60. So you should end up with L squared as being 160. And then we need to take the square root of that, which will be L is going to be 12.65, and that's meters. All right, here we go with number 9. The volumes of two similar rectangular solids are 2,700 cubic centimeters and 800 cubic centimeters. What is the ratio of their surface areas? Well, if we have a ratio of A to B, what we talked about for volume, we will say A cubed to B cubed. And this is volume. So to get my A to B ratio, I need to take the cube root of 2,700 over 800. That will give me my A to B ratio, because A to B will be the volume cubed, these A cubed to B cubed. That's how I get from the sides to the volume. So to undo it and just get my regular A to B ratio, I just need to divide those two. So in this case, if I take the cube root of 2,700, I will end up with 13.92. And if I take the cube root of 800, I will end up with 9.28. But I can do one step first and just reduce this to be 27 over 8, and then look at it in this sense. So if I take the cube root and reduce it first, what's the cube root of 27? It ends up being 3. The cube root of 8 ends up being 2. So it's easier to reduce it and look at it in that sense. So this A to B ratio comes out to be 3 to 2. Okay, so now I need to finish this question. So finishing this question says, this is the ratio of whatever the sides would be, but I need areas. Since I need areas, I need to square that ratio. So I have to take my A to B, which is 3 over 2, and I square that to get an area. And that comes out to be 9 to 4. So that is the final answer there. So what I had to do first was get the A to B ratio, and then I could square that to get the area ratio. Okay, to the nearest cubic foot, what is the volume of the composite figure of both the height and diameter of the cylinder are 1.4. So if this is 1.4 and that's 1.4, if both the height and the diameter, the diameter 1.4. Okay, so that means the radius is going to be 0.7. I need to break this up and do it as two separate problems. I could do the cylinder, the volume here, plus the volume of this hemisphere. So the volume of this cylinder is going to be pi r squared h, which is pi times 0.7 squared times the height of 1.4, plus the volume of this hemisphere is 1/2 times the 4/3 pi r cubed. So this ends up being, this will reduce with that. So 2/3 pi times 0.7 cubed. So that's how I get the 2/3, is because I just reduced that in there. All right, let's work all this out. So we've got 0.7 squared times the 1.4 gives me 0.686 pi. So 0.686 pi plus 0.7 to the third times 2/3 will give me 0.2287. So we'll say 0.229 pi. So 0.229 plus 0.686 gives me a volume of 0.915 pi, and you can multiply this out and you'll get 2.87. So the volume is 2.87 cubic feet. Moving on to number 11. Determine the volume of a sphere with a great circle that has an area of 16 pi. Give the answer in terms of pi. Okay, so here we go. This one, we do need to leave it in terms of pi. And we have a sphere with a great circle that has an area of that. So basically what this means is the great circle is this right inside of here. That area, I'll use that to get the radius. So 16 pi equals pi r squared. So that means the radius is 4. Now I can find the volume. The volume is 4/3 pi times 4 cubed. So 4 cubed times 4 divided by 3 gives me a volume of 85.33 pi cubic centimeters. All right, for number 12, to the nearest cubic centimeter, determine the volume of packing peanuts needed to fill the box if the radius of the enclosed cylinder is 4 centimeters and the cylinder is centered in the box. So basically, we've got to fill up this box. Let's do a different color here. We've got to fill up all the stuff in this box, assuming this object, this cylinder's in it. So how much volume do we have left? So what I need to do is I need to find the volume of this minus the volume of that. And that'll give me what's left inside of it. Well, this one is 28 times 8 times 18. This volume is going to be the area of the base, which is 28 times 8 times the height, which is 18. This volume, they told me that the radius is 4. So the volume is pi r squared h. So this ends up being, we're going to subtract pi times 4 squared times the height, which they indicate is 12. So let's work this out. 28 times 8 times the 18 will yield 4032 minus 4 squared times 12, and I'm going to multiply the pi through this time, 602.88. So 4032 minus the 602.88 gives us a result of 3429.12 cubic centimeters. All right, almost there. A couple more problems. Okay, convert to degrees and radians. So for this first one, this is a radian. Whenever you see a pi there, it's going to be a radian measure. So this, we know that 2 pi out of 360 is our conversion from radians to degrees. So we set this ratio up. 2 pi out of 360. Since this is a radian, I'm going to put it right here. 22 pi over 13, and I'll put my x right there. Cross multiply. 2 pi times x equals 360 times 22 pi over 13. Right away, we'll notice the pi's will reduce. So we end up with 360 times 22 divided by 13 is 2x is going to equal 609.23. Now divide by 2, and you will get 304.62 degrees. This problem is the same way. Be careful with that negative. So we'll say 2 pi out of 360 is negative 230, and my x this time will go up there because I want the radian. Cross multiply. So you're going to get negative 460 pi equals 360x. So negative 460 divided by that 360 is negative 1.277 pi. That's your x. And if we kept this as a fraction, that ends up being negative 23 over 18 pi radians. Okay, we are on number 14. This is the last one here. Find the area of the shaded region and the arc length, QS. Oh, I should have put another point. So I indicated here QS. I wanted this QS this way. I should have indicated another point, but that's okay. So let's find the area of the shaded region first. So what we have is we have a portion out of the full 360 degrees times pi r squared. So this portion is 293 degrees times pi times your radius, which is 10 squared. So 100 times the 293, divide that by 360, is going to give me an area of 81.39 pi square centimeters. So the arc length, S, will be 293 out of the 360, but this time we've got 2 pi times 2 pi r, which is the circumference of a circle. Again, be careful. In this question, I should have worded it better. I'm asking for this along the shaded region. Okay, so this becomes 293 divided by 360 times 2 times our radius, which is 10, yields an arc length of 16.28 pi square centimeters. Or just centimeters, sorry, just centimeters. All right, hopefully this review helped, and good luck on your test.